Okay, Assalamualaikum again dan selamat pagi. uh, Again kita berjumpa for our second session on project discussion, right? So during the first session tadi, quite some time was taken to explain the difference between suspended dengan non-suspended ground slab. Okay, so by looking at the reason why saya explain tadi was by looking at the cross-section view of the architectural punya drawing, okay, from the cross section dan juga from the elevation, we can clearly see that the ground slab for the building is raised up lebih kurang around 450 mm from the zero level ataupun from the original ground level. It has been raised up about 450, meaning that there will be a lot of filling di bawah the ground slab tu, because naturally it will be filled up with soil di bawah ground slab. And for that reason, I would suggest ataupun I would recommend that for the ground slab of the project work, it has to be designed sebagai a suspended ground slab. Okay? Meaning if there is any settlement of the soil beneath the slab at the ground level, the settlement would not affect the ground slab. The ground slab is directly supported by the ground beams, as we have seen earlier in our first session. So my recommendation would be the ground slab to be designed as a suspended ground slab. So this is the information that we can extract from the architectural drawings, and from that architectural drawings we come to a conclusion in terms of structure. In the structural sense, now we are designing the ground slab to be a suspended ground slab. So this is one of the techniques. By looking at the cross section of the architect building, of the drawings from the architect, we can come to make certain conclusions. For example, like in our case dalam contoh ni, by looking at the ground slab to be a raised ground slab, okay, around 450 mm. This is the approximately 450 mm. Okay, this 450 mm sebenarnya from the if we have a look at the slab ni, ground slab ni, ground floor plan. Okay, is this the ground floor plan? No, and this is the ground floor plan. Okay, so we can see that there are some steps di sini from ground level untuk going up to the coming up to the building. There are certain steps di sini, so we can safely say that if we were to take a cross section of the steps di sini, okay, of these particular steps, then it would look something like this. Would be our ground level, and then we will have our first step, okay, second step, and then kita punya building level. Okay, apalah, it's just a sketch kan. So we can say that each R ni, each riser di sini, okay, each R ni, we have 3 R di sini, okay, 3 risers, another R di sini, and finally another R di atas sekali. So we can say that there are 3 steps coming up, 3 steps coming up, and each R to be approximately 150. So that is why going up the staircase, the steps at the front portion, it is an increase of 150 mm. So we have 3 steps di situ. Maka this concludes that the elevation of the ground slab is approximately 450 above the ground level around the building. Okay, just by looking at this, we can see that the ground slab of the building is raised up by approximately 450 mm. Clear? Okay. So again, back to the sketch that we have looked at earlier. Okay. And one more thing, since it is to be a raised condition ataupun a raised ground slab, then if we were to have a look at this particular condition di sini, okay, then we would have something like a ground slab, kemudian ground beam, suspended ground slab and ground beam. okay, the difference between the slab, ground slab dengan the existing condition ataupun the level outside of the building is around 450. So what this implies is that the depth of this particular ground beam ukur dalam rasuk ni has to be more than 450. Okay? If not, nanti tergantung. The depth of this beam, this particular beam di sini, the full depth of the beam, okay, has to be more than 450. Let's say around 600. Okay, so you need to choose this particular dimension has to be more than 450. If not, then there'll be a gap between the ground level dengan the ground beam. There is a gap. Okay, so make sure that the size, the depth of this ground beam is not less than 450 mm because, and this is all around the building. Sekeliling bangunan tersebut, all the ground beams, okay, on the perimeter part of the building, especially di sini and at this position, the depth of the ground beam has to be more than 450. If it is less than 450 ataupun equal to 450, then there is a possibility that if any settlement of the ground ground settlement, then it will leave a certain gap below the ground beam. Okay, and this gap, all sort of things boleh masuk, insects, binatang-binatang, ular ke apa yang boleh masuk below the ground beam and into the underneath the ground slab. So pastikan, ensure, because the architect has indicated that the ground slab to be 450 mm above the ground level. Therefore, the perimeter ground beam, okay, or this is the perimeter ground beam, has to be deeper than 450 so that it covers the whole exposed condition. There will be no parts of the beam ataupun there will be no parts of the gap between the slab dengan the ground condition, the soil ataupun the ground level. Right? So this is another information that we can extract from the architectural drawings. Okay, I'll save this. Okay. So this is part of your observation sebenarnya. Part of the observation that you need to do. Each group look for things that are listed dalam architectural drawings. At the same time, it can be used as part of our structural punya input. Okay, so we've looked at dua benda tadi. One is the ground slab. We've come to a conclusion. It has to be designed sebagai a suspended ground slab. That is one. Number two is that the perimeter ground beam, all the perimeter ground beams has to be deeper than 450 mm. Okay, maybe 600, maybe 650 mm. Okay, that would be a reasonable dimension, so that it covers the whole depth of this 450, the difference between the ground level dengan the first dengan the ground slab level, right? Other information that we can extract from the architectural drawings adalah, of course, the dimensions. The column height indicated here is about from floor level kepada floor level is approximately 3.6 meter, and it is equal from ground floor kepada first floor, and from first floor to the top of the roof beam is approximately 3.6. So we have dimension, the column dimension is indicated di sini. The height of the column is approximately 3.6. And satu lagi is that there will be some cantilevering out of the, you will have some cantilever punya conditions. For example, well, I'm now looking at the first floor, okay, the first floor plan. And clearly dalam first floor plan ni, because the columns were located pada ground floor-nya di sini, this position. So at first floor, the columns are located somewhere di sini. It's not right at the end, tetapi somewhere about 1.5 meters, tak silap saya, about 1.5 meters, okay, 1.5 meters into the building. So this indicates that this part of the column ataupun this part of the beam is a cantilever beam. Meaning, yang saya maksudkan is something like this. If we have a beam sampai di sini, okay, then this portion of the beam that is connecting between these two columns. And remember, when you are coming up with a structural plan ataupun a framing plan, you need to indicate the floor plan according to the architect's floor plan. You start off with the ground slab, ground level, kemudian first floor level, and finally the roof beam level. So you will need to produce structural framing plan indicating the position of columns dengan position of beams, okay, and secondary beams if you need to put some secondary beams into the drawings. Okay, so one indication di sini is that columns ni, when you're putting up a framing plan for the columns, okay, pastikan all columns are connected to each other with beams, meaning that you will have, remember sini sebenarnya ada column ni, tapi the column, of course the column will stop sini, it will not continue. There is a column below, okay. Di sini the column continues up because the column is in in a position similar to the brick wall, so the column does not obstruct the use of the room. However, if this column is allowed to go up sampai kepada roof level, then within the classroom tiba-tiba ada tiang. Okay, so physically we cannot allow any columns to be within a classroom. Kalau within office tak apa. I mean, if this is an office punya space, then I wouldn't mind the columns to be exposed dalam office space, because it will not obstruct anything. It will not cause the function of the room to be forfeited ataupun to be jeopardized. Dia tak mengurangkan atau tak mempengaruhi kegunaan ruang. Tetapi kalau classroom, if you have a column somewhere in the classroom, exposed column, column yang nampak, even though taklah di tengah, di tepi, tapi however, the column will obstruct the view of the students within the classroom. Okay, right? Kalau kita pergi mana-mana panggung wayang pun lah, mana ada tiang kat tengah-tengah tu kan? Mana ada tiang tengah-tengah panggung wayang? There is no columns center of a cinema. Okay, there will be no columns because that will obstruct the view and it defeats the purpose, the function of the room. For our visual punya purpose, it defeats the function. So we cannot allow the columns which is located di sini. We have a column below sebenarnya. Remember, our column to column center is 4.5. So there is a column below, but the column stops at first floor. It does not continue kepada second floor. Okay? Which means that the beam connecting this column dengan this column at roof level will now be 9 meters. Sekejap hold on sekejap. Okay, sorry, sekejap, ada delivery tadi. Okay, right, as I was saying that in our layout, when you're producing your layout, you cannot allow this column to go up from first floor kepada roof. Okay, from first floor kepada roof, it cannot go up. So it has to stop pada first floor. Kalau maksudnya, if I were to sketch di sini, just to sketch, we have kita punya dalam arah memanjang longitudinal punya direction. This is my column. Sorry. This is my column. Okay. This is my ground floor. My first floor beam, and my roof beam. Katalah, this is my first floor beam, roof beam dengan my ground beam. Tebal sangat. Okay. And I have my columns di sini. Yang ini exactly di sini. Okay. I have my column satu lagi. At 9 meters, another column di sini. And one more column di sini. So what I'm saying is that the column that is located at 4.5 meters ni, okay, cannot continue up kepada roof beam level. This is my roof beam level. This is my roof beam. Roof beam. Ini saya tengok longitudinal punya section. My first floor beam and my ground beam. My ground beam. Okay. So I have my columns which is yang kita tengok tadi earlier, space at 4.5 meters. Dalam arah memanjang ni is 4.5 meters. This is 4.5 meters, and I have another sebelah sini another 4.5 meters. Okay. At from ground floor kepada first floor, I can put up the column. Tak ada masalah sebab dia tak mengganggu. It does not obstruct the view from ground floor kepada first floor. This will be my 4.5 meter. And this also will be my 4.5. However, from first to second floor to the roof level, because the column is now located within the classroom, okay, therefore the column has to stop di sini. Which means that now at the roof level nanti, the span of the beam is now 9 meters. This is the span of the beam, 9 meters. Okay, so this is the implication from observing the architectural punya drawings, and from there we come to a conclusion. Okay, in the longitudinal direction, we can have columns spaced equally at 4.5, tapi certain columns cannot continue up, naik ke atas, because this is at the center of the, not at the center, it will obstruct the view within the classroom. This particular column yang sebelah kiri dengan sebelah kanan is okay because we have a brick wall di sini. Okay. Brick wall location somewhere di sini. There is a brick wall location di sini. So the column coincides with brick wall location. Okay. The column coincides with the brick wall position. So it does not obstruct the view. Okay. It does not make the classroom ataupun obstruct the views of the students within the classroom. Tapi there is no brick wall at the center di sini, and therefore the column has to stop. Because kalau ada brick wall di sini, then the column can continue up. Because the column will not be obstructing anything, because dah memang ada brick wall. So this is another information yang we can extract daripada the architectural drawing. Okay, so clearly at the first floor level, okay, columns yang at this position will have to stop. Will need to stop, okay, at this particular location. All columns at this position, at this position, at this position, dengan at this position will need to stop. Will stop at first floor, and which means at the roof level, the beams will now be spanning 9 meters, 9 meter, which is a big span, rentang yang besar. Tapi fortunately, at the roof level, tak ada slab lagi dah. There is no more slab. It is just void sahaja lah. Void. Okay? Empty space dekat atas tu because we are using trusses dan sebagainya to come up. It's not a RC flat roof. Kalau RC flat roof, then it will be much heavier, lebih berat lagi lah. Okay? And the span is 9 meters. Okay? So meaning now we are working our way slowly. Okay? Tapi surely we are moving in the right direction. Dah kita tengok some critical points. Okay? As I've said earlier, this column dengan this column it's okay because dia in line dengan brick wall. So it is not obstructing anything. Tapi to have a column di sini, walaupun this at the side of the classroom, but it will defeat the purpose of the visual for the students. So the students will be obstructed, the view will be obstructed by the position of the column. And that is the reason why the column stops at first floor level. Meaning it will affect the span of beams at roof level from 4.5 menjadi 9 meter. Okay. Span of beams at first floor is 9 meters in this direction, dalam arah ini. Tapi in the same direction for the roof beam levels, it will now be about approximately 9 meters, 9 meter. This is the implication. Dan juga implicationnya ialah there will be some cantilever portion. Kalau tengok sini, kalau if I take this to be my beam, remember beams will connect all columns. You will need beams untuk all columns to be connected to each other by beams. And then you have beams in this direction, you have beams in this direction. Okay, this is your framing plan. Okay, you will have beams in this direction juga. Okay, and not forgetting there will be beams di sini juga. At the end ni L beam ni kat ujung. There will be beams di sini, and also there will be beams on the side. Okay, so pastikan when you're coming up with the framing plan, first thing is that all columns have to be connected by beams. You need to connect to connect all the columns with beams. Jangan biarkan columns not connected to any beams. It has to be connected to, but from column to column, it has to be connected with beams. All columns macam itu. Right? So this is a typical layout untuk first floor. We still have our support di sini. Cuma this part of the beam, okay, this part of the beam is cantilevering out. Similar to this portion, there is a cantilever out on this part. Meaning kalau saya ambil a typical cross section in this direction, okay, in this direction, then again kalau kita tengok pada sorry saya savekan itu. Meaning kalau in the transverse direction, tadi kita tengok longitudinal, in the longitudinal direction. In the transverse direction, we will have columns. Okay, columns. This is my column, and this will later on, and nanti I will have my foundations later on. Okay. This is my column. My ground beam. Ground beam. This will be my ground beam. Something di sini. Okay. Somewhere here. The first floor beam. And my roof beam. This will be my typical cross section. Ini section yang mana column will continue up sampai roof. Okay, the columns will continue up sampai roof level. Dan ini columnsnya within the brick wall. So we have a cantilever portion di sini. There is a cantilever portion here dan cantilever portion here. And the span between yang ini ke sini is as we've seen earlier, this would be around 7.5 meters. Ini about 7.5 meters. Okay, 7.5 meters. So this is where the columns are allowed to go up sampai roof level. But remember, ada juga portion yang mana the columns stop. Okay, so yang ini saya save dulu. So when the column stops ni, bermakna yang ini is somewhere di sini, stops here, somewhere there. Okay. Now you might ask, sir, macam mana ni tak ada column nak kat atas ni? What about the beam at roof level? What is supporting the beam sekarang ni? Remember yang 9 meter tu, the beam yang 9 meter yang ni, this beam ni, this particular beam ni, this particular beam which is 9 meters. Now this beam will now act as support, bertindak sebagai penyokong on this part. This now the roof beam that is supporting another roof beam. We have a main roof beam supporting a primary supporting a secondary. Something macam kita dengar masa staircase saja kan. Okay? So this is the portion where yang ini at this portion sini, at this particular location. Tadi the first sketch tadi was location yang somewhere di sini, where the columns can go up sampai roof level. Okay? But at portions where column cannot go up sampai roof level, then this would be the location something macam ni. Of course there is a column juga, tapi the column that is supporting this red beam ni, column yang ini, which is 9 meters apart. Ini yang 9 meter ni. These two columns ni supporting the red beam yang ni, this beam, and this beam is now supporting dia punya roof beam somewhere di sini, somewhere here. This is what we see in this section where columns stop at first floor. It does not continue naik sampai ke atas. So meaning the roof beam at this portion, still there must still be a roof beam dekat sini, but this roof beam is supported by column on one side, but on the other side, on the other end, it is being supported by roof beam. Pada position, at this position, at this particular position, where the columns stops at first floor because of the constraint of the use of the classroom dekat atas ni. We cannot allow the columns to go up sampai roof level because of the restriction on the use of the classroom. It will it will obstruct views for students within the classroom. Kalau if we allow this column to go up, then it will obstruct the view of students within the classroom, as shown dalam architectural drawing. So these are all the important features ataupun information clues that we can extract daripada architectural punya drawings, and this will form our structural, basic structural punya framing plan. And remember, each group you need to produce basically scope of work dia lah. Saya pun tak sebut lagi pasal scope of work ni. What do you actually need to do dalam your project ni, project, save this. Okay. The first stage is to prepare your schematic drawings, your structural drawings ataupun your framing plan for the ground floor. Okay. For ground floor punya beams and columns pada ground floor, kemudian pada first floor and pada roof. So you need to produce three drawings. Okay. You can use AutoCAD pun boleh, you can use manual pun boleh, tak apa. Tapi gunalah pembaris. Kalau straight line tu guna pembaris. Janganlah freehand pula. Saya tak apalah freehand. Okay. So you can use manual punya sketch or AutoCAD punya sketch drawings. It doesn't matter. It's okay to me. As long as each group produce yang ni, the first stage. This is our first stage. So within these 2 or 3 weeks, okay, 2-3 minggu ni, this is our first discussion. The next discussion will be around 2 to 3 weeks lagi. At that stage, hopefully semua dah produce your framing plan, and kita move on kepada the second stage. The second stage will akan buat analysis and design of one beam dengan one slab. The third stage will be the design of one column and one foundation each, dengan one staircase each. Setiap ahli will produce one design on staircase, one design on one column, and design on one foundation. Tak banyak. One column, one foundation, one staircase. Okay. That will come stage number 3. This is our first stage. To produce this drawing dulu. So each group concentrate on the first stage dulu. Okay? Try to produce a drawings, and the drawings should indicate not just the location but the sizing. What would be the sizes of columns and beams and thickness of slab, thickness of staircases, all this. What would be the sizes? And it has to be indicated in the drawing. Dalam drawing tersebut, tuliskan size dia. What is the size of this particular beam? What is the size of this particular column? Dan sebagainya. And how do we come up with the sizes? Again, this is what we've come across earlier dalam staircase. Gunakan L over D. Okay? L over D, approximately 15 for beams and approximately 30 for slabs dan juga staircases. So this will give the indication of the thickness of beams dan juga slab. What about the width of beams? Then you need to fall back kepada your fire requirement. For a 2-story building, a 1 hour fire protection would be sufficient pada pendapat saya lah. Maybe setengah kata, sir, our group wants to use 1.5 hours, sejam setengah, which is 90 minutes. Okay, it's okay, boleh. So you can choose to use 60 minutes pun boleh, 90 minutes pun boleh. Mungkin saya tanya, why are you using 90 minutes? Mungkin dia kata, sir, because sekolah ni we are assuming sekolah rendah. So sekolah rendah ni bermakna instruction tu kadang-kadang yalah bandingkan sekolah menengah ataupun university student kan. You give instruction pada sekolah rendah ni, dia kata turun ikut tangga kiri, dia pergi ke tangga kanan kan. So things like this, because and then for that you allow longer punya 90 minutes punya fire resistant. It's okay, boleh. So lebar beam, okay, the width of the beams, okay, you can use fire requirement dan juga columns. Okay, sizes of columns we refer pada fire requirement, right? Okay, so this would be your first stage punya scope of work. Peringkat pertama, within 2 to 3 weeks lah, kita bagi masa 2 hingga 3 minggu. Mungkin sekarang minggu kedua, minggu keempat atau minggu kelima, we'll have our second discussion on the project. And at that stage, I would like to see all the groups punya the layout for each group. We'll be discussing that pada peringkat kedua. Tapi peringkat pertama is for you to produce all the necessary schematics indicating your layout, the beams, primary beams, secondary beams dan sebagainya, sizes of column, thickness of slab, size of beam dan sebagainya. And satu lagi, when we're talking about, balik tadi kepada our earlier discussion, when we were talking about yang ini, boleh tak saya redo balik? Redo, tak boleh, undo. Okay, earlier I've indicated that I would like to put my, katakan contohnya my beams in this direction, ada beam. Okay, I have my beams in this direction. I have my beams in this direction. Okay. I have my beams juga in this direction, with cantilevering on the left hand side and the right hand side. I have my beams juga in this direction. Remember we have a column below sini, ada column ni. Cuma the column stops at first floor. Tapi at first floor, di bawah first floor, exactly at the first floor, there are still columns kat situ. Okay, bermakna we still have our columns. Kat sini masih ada columns. Cuma dia tak continue from first kepada second floor. So this will be my column position. These are all my column position. Indicating yang ini sepatutnya continue. Sepatutnya continuous. Right. So this is generally method. Dan from the layout sini, I can now identify, okay, for this particular slab, okay, slab ini, for this particular slab, katakan saya ambil satu slab ini, my LX is approximately 4.5. Okay. LX, my LX is approximately 4.5. My LY, okay, my LY value is approximately 7.5. for this particular slab. Meaning, if I were to use to estimate the thickness ni, L over D approximately 30 kan. Now the L that I'm using for slab ni is now using LX. So berapa dapat? Atika, where are you Atika? 4.5 bahagi 30. 4500 divided by 30. Berapa dapat D?
150, Doctor.
Berapa?
150.
150 Okay, 150. D dia. Meaning my H, I can easily choose around maybe 175. Okay, 175 mm, including cover dan sebagainya lah, 25 mm dan sebagainya, 20 ke 25. So my overall thickness is approximately 175 mm. Okay. Now if I want to reduce this thickness ni, I want kata okay lah, 175 ni a bit on the high side lah, katalah. You choose to reduce the thickness, what you can do is to introduce what is termed sebagai kita punya secondary beam sini. I can introduce a secondary beam sini. Walaupun there is no brick wall. Okay? Even though there is no brick wall, I can introduce a secondary beam sini. And when I introduce my secondary beam sini, my LX sekarang ni, okay, my LX menjadi 2.25. For one typical slab ni, okay, my LX is now 2.25. Kalau 2250, Atika, bahagi 30, what would be my D? My new D. Tadi 150. Sekarang ni 2250 bahagi 30. 75. Bermakna, my slab thickness yang ni, I can use 125 dah cukup. This is my beam. Okay. The slab yang ini can now be reduced to 1 to 5 mm sahaja. 125 mm thickness of the slab. Okay. So this is how you can explore. Okay. Explore in terms of sizing. Kalau dimasukkan secondary beam, the slab becomes LX dia menjadi lebih kecil, 2.25. Original LX is 4.5. I need a value of 175. Okay. Originally, this value is 175. Now, if I insert a secondary beam di sini, then this slab becomes thickness dia can be reduced from 175 menjadi 125 mm requirement dia. Okay. And moreover, by introducing the secondary beam, maka the slab becomes, nampak macam one wheel, 2.25 divided by 7.5. It's more than 3, it's more than 2 kan? So, it now becomes one-way slab. Semua ni jadi one-way slab. By introducing a beam di sini, all this will become one-way slab. Introducing secondary beam. This will be all one-way slab. Papak sahala. Okay. So this is the option that you have. Okay. You can maintain as it is, maintaining LX there 4.5. Then you would roughly require a thickness of 175 mm for the overall thickness of the slab. Or you can try to reduce the thickness of the slab by reducing the span. To reduce the span, maka that is the reason why kita introduce the secondary beam. The secondary beam is introduced so that the LX is now reduced from 4.5 menjadi half the value, 2.25. And when LX is reduced kepada 2.25, consequently the thickness requirement is now reduced from 175 previously kepada something like 125 mm sahaja. So that is the, orang kata, the pros and the cons, okay, of looking into a layout and trying to reduce the thickness, adding secondary beams dan sebagainya. Okay, so I leave that to you.